Welcome to this live session of Natural Gas Engineering. I'm Dr. Pankaj Tiwari, the course instructor for this course. I'm here to help you out with your queries, with your questions, doubt, and anything related to natural gas engineering you have in your mind. You can ask me. I'll try my best to answer it. Thank you. So by the time you will write your queries in the live chat, I'll take some question from the Excel sheet. Can you please put up Excel sheet? First, Mayer Khan se, no question. Dinesh Kumar Tripathi, no question. Dinesh, do chemical engineers have any opportunity in upstream sector? Opportunities are there. Even chemical engineering is very close to the petroleum engineering in terms of understanding the properties of the fluid, rock properties. But yes, specialization is required to work in the upstream, and mostly the companies those are in the upstream they look for the petroleum engineering background student. But I had seen in my life when some of my friends are working in the upstream while they were having the chemical engineering background as in their education. So opportunities are there. You may explore the upstream companies opportunity. I think there is a good scope for chemical engineer there. For chemical engineering student based on this course, yeah, this course will help you. Like you might have seen, this course is designed like for natural gas engineering, but altogether it's teaches you about the upstream production of the natural gas. Similar concept, not exactly similar, but like same concept were applied for the oil production. Moreover, in this course, you are not having only the upstream segment, you are having the middle stream also, where you are processing the natural gas and then you are having this transportation of the natural gas also. So it will, this course gives you a fair idea about the petroleum engineers, or specifically the natural gas engineer do work in the field and in the processing of the natural gas. Another question from Vera. He asked, is there possibility of any internship opportunity under you after doing this course? I open the opportunity for the internship every year, but not very specifically for the natural gas. I do work in some other area also, like the pyrolysis of the plastics, biomass, enhanced oil recovery, where I'm working on chemical enhanced oil recovery and microbial enhanced oil recovery. But if you are interested or anybody interested to start the internship with the natural gas like gas hydrate and other component, I would be happy to offer such kind of the opportunity for you. It will depend on like where you are currently, what kind of the internship you want to do. But we can have a good talk about it. Please write to me over the email. I can discuss the things further. Thank you. There is no other query in the Excel sheet, so I have to take the question from the live session only. So I request all of you, those are watching this video, please ask your queries, because if we see the queries are not there for a significant time, then we might have to shut off this event. So I would appreciate if you keep asking the question and maintaining the continuity of question and answer session. You may put the slide so I can discuss the syllabus. So in general, what I do in the live session when I don't get any questions, I discuss the course content, and that's I'm going to do again. That helps you uh, to understand the design of the course. That will help you preparing for the examination also. So like this course is a 8 week. This course is a designed for 8 weeks. Total 21 lectures were designed. And if you see from the beginning, it gives you a good flavor about the importance of natural gas. Natural gas, a substance that was very, very useless when the oil were explored, but later on it is becoming the fuel for the future. If you see the gas hydrate, people are working exploring the gas hydrate. It's becoming the future's fuel. So the introduction give you fair idea about the place of natural gas occupying within the fossil energy sector and the classification of conventional and non-conventional natural gas productions. And then important is properties of the natural gas. So the second week discuss about the properties of the natural gas, where we started learning how to calculate the density, viscosity, compressibility factor, means all the properties those are required when you are producing the natural gas, when you are refining the natural gas, when you are transporting the natural gas. These properties are required to design the equipment to transport or handle the natural gas with the safety features. Then the third week was very important because here we had discussed the IPR, inflow performance relationship, how the natural gas is produced from the heterogeneous reservoir system to subsurface, from subsurface to the surface. And once we have this IPR relationship, how to test the gas well, that was discussed in week 3. And week 4 is about other two segment of the petroleum production system. Here this is the WPR and this is CPR. So we are having WPR and CPR segment there. And then the nodal analysis was discussed. So this is the concept where you can eliminate one of the unknown by identifying or by selecting the node where the two physics or two equations are getting merged, and that is a common point. We can eliminate, like when we are considering the IPR and WPR, we can eliminate the pressure or a property set bottom hole condition. When we are dealing with the WPR and CPR, we can eliminate the point at the chalk performance point or PHF, wellhead pressure conditions. So that was discussed in this segment. And then in the coming week, we discussed about the processing of the natural gas. So once the natural gas comes to the surface, it needs to be separated because natural gas is not produced alone. It is having some dissolved, some oil, some water, and some sand particles also. So a good design of the separator is required. We discussed about the two-phase separator, three-phase separator, horizontal separator, vertical separator in this segment. And then the natural gas dehydration, how to remove the water, and the sweetening means removing the sulfur compound from the natural gas was discussed. In entire process of natural gas dealing, we need the compression station, and the design of the compression station, the power required to compress the natural gas from pressure P1 to P2 was discussed in detail in the compression design lecture. And then it comes to the measurement of the natural gas. So when we are transporting the natural gas, when we are having the business for the natural gas, we deal about measurement of the natural gas. What are the techniques are there? Those are continuously monitoring the natural gas flow rate in the field or in the particular point. That could be the station point, that could be even the home where the natural gas is supplied. And then transportation of the natural gas, so different mode of the transportation like GTL, uh, through pipeline, through LNG was discussed in this lecture. Major emphasis was given on the transportation of natural gas through the pipeline. So we discussed about the series pipeline combination, parallel pipeline combination, or the combination of series and parallel. And that discussion was done to maximize the throughput, to maximize the amount of the natural gas that can be transported from point A to point B. And that point A, between the distance between the point A and point B is not just a few meters, it is several kilometers, several thousand kilometers sometimes. And then we discussed the special issues with the natural gas production like the hydrate formation, liquid loading. And then the unconventional production of natural gas. So we are having the shale gas, tight gas, gas hydrate, even the biogas. So those segments were discussed. Those are still the unconventional way of producing the natural gas. And then a review class was taken. So yeah, altogether 25 lectures were designed in this 8 weeks class course. So if you see this production system, the important emphasis was given on the production system. So this is schematic diagram for any type of the hydrocarbon production from the reservoir. So we are having in the bottom the reservoir here through which the fluid is traveling to this pipeline. We call this is a WPR, whatever we develop here, the mathematical relationship. We called it Well-Bore performance relationship. Here it is IPR, inflow performance relationship. So there could be several cases like the type of the fluid, the type of the geometry. We simplified our approach. We consider the fluid is the compressible fluid, that is our natural gas. It is compressible by the nature, means its volume changes with the pressure. Second, it is our geometry we consider is a radial geometry, means the fluid is traveling from all the direction and reaching to a point where we are having the perforated region. Through this perforated region, the fluid is traveling up and we are getting the fluid in this pipeline. This pipeline is not just a few meter, again it is a several thousand meter through which the fluid is traveling vertically and reaching to the surface. At surface we are having this Christmas tree. We call it is a place that is only visible when we are visiting the reservoir field. And within this Christmas tree we are having a device called the choke, and that's actually regulate the flow at which we want to produce natural gas. So I set up the equations here. If you see, oops, so this is the mathematical relationship for radial flow for a fluid that is compressible in the nature, and we did this for a case of pseudo steady state. We can have a steady state condition, pseudo steady state condition, or the transient condition in the reservoir production system. But what we do, or what exactly happens, the transient condition is at the early time when we just start producing. So the pressure is just getting established. We are having the transient zone and then late transient zone. After that, we are having the pseudo steady state condition. And most of the time, the reservoir produces under the pseudo steady state condition. The steady state condition means we are able to maintain the pressure. So if there is some mechanism by which we can maintain the pressure in the reservoir, then we are having the steady state condition. Because it is not easy to maintain the pressure, or in the oil field we can maintain by injecting some water or gas, or having a nearby water aquifer, it can be maintained. But in case of the pure natural gas or gas well, we are having the pseudo steady state condition most of the time. So the equation was developed for pseudo steady state condition only, and here S is account for the skin effect and this dq term for the non-Darcy flow, because the equation is derived assuming the Darcy law exists or applicable in this reservoir system. But we know Darcy law is limited, it has its own limitation. The foremost limitation is the flow is a laminar condition, but that's not going to be near the Well-Bore region. That's why we are having this dq that accounts for this non-laminar behavior, or I would say turbulent behavior. That's why it's called the dq, called the correction factor, or a term added in the gas reservoir diluent equation to account for that term. Second, we are having this WPR. So WPR, just we have to do the balance for a pipeline through pipeline. Here it is going in a vertical direction, or the angle is adjusted by this theta. Okay, and the next equation is for the CPR, where you are having the choke performance relationship. It will again depend at what condition we had set up our choke. It is flowing under the sonic condition or subsonic condition. So the critical pressure ratio will help us to estimate the situation, and accordingly the equations should be used to calculate the flow rate at the choke conditions. And so this is the overall profile or overall picture of the conventional natural gas production that we discussed in the entire course. So IPR, WPR, CPR, properties of the natural gas, separator design, separate parts of the purification of the natural gas, extracting the important compound like this NGL or LPG from this natural gas and selling out. It's at a higher cost. And the third segment is about the production of natural gas, sorry, the transportation of natural gas by different means. So this chart shows like it depends on the quantity and the distance, how much quantity you are supposed to transport from point A to point B, and what is the distance between point A and point B. If it is a several thousand kilometer, then the most convenient way is the pipeline. But if the quantity is not very much and the distance is also not much, we can go with the option of CNG, that is the compressed natural gas. Similarly, depend on the combination of distance and the quantity, the option could be LNG, this is liquefied natural gas, or GTL, gas to liquid, means you can convert gas into the liquid and then you are transporting it. Remember, the natural gas that we get from the reservoir, it is unrefined natural gas. But the natural gas that we sell to the consumer, it is mostly the pure methane. I think with this, I revise the syllabus once again. I'll just take some question if there are. Where is YouTube? Okay, it is here. No questions so far. So the common question, again, I can talk based on my previous experience. You guys might be having in your mind what type of the questions will be there. Do you need to remember the big formulas? Because this course is having a very big expression even for the estimation of the properties. We are having some empirical correlationship, and for these equations or for the design of the equipment, we are having some complex expression. So I would like to emphasize again and let you assure, like you don't need to remember any big expression. Just the fundamental of the natural gas course, those are taught in this course. You need to go through them. Very basic thing like what is the Reynolds number for the natural gas when it is flowing through the pipeline. Those small things you have to. Those also based on the concept like Reynolds number is rho Bt by mu. How to convert this into some useful quantity. Those are applicable for the transportation or handling with the natural gas. Those you need to be keep in your mind, otherwise you don't need to remember any big expression. So the course content, whatever is taught in this course and the slides are good enough to go for the exam. But to enhance your knowledge or something, I also provided a list of the books or the material from where I had taken most of the material also. You can go through them. Thank you. You may put slide. Yes, so I got a question from Mr. Bera. He asked, is there any chance of internship under you after completing this course? I already answered this question. I said, please write to me. I'll discuss with you over the phone or something and we will figure out is it feasible or not in the current time situation. And it also depends on what area you want to do internship is the facilities are available at the institute or not. Okay, so please see the video in the beginning. I already answered this question in more detail. Another question from Mr. Banerjee. I have not submitted the assignment 3 and 4. Can I take the exam to get this certificate? I think you can do it because the assignments are carrying some marks. So if you don't submit the assignment, you will be losing some marks. So the final grade is a combination of the marks you scored in the assignment as well as you score in the examination. So if you are confident enough, you can pass the course just without counting the assignment 3 and 4, you should go ahead. I don't think there is any option where I can allow you to submit the assignment 3 and 4 because the solution is already out for all the assignments. If you want a more clear answer about it, you may write to IIT Madras nodal team. They may help you. But as far as I understand, you can still register for the course to uh, get the certificate. Input the slide. So the next question is from Pritam Banerjee, and he is asking about any chances of exam questions from the assignment. So it is, you're talking about the exam, so I cannot reveal other than the pattern of the exam. I cannot reveal the question will be taken from the assignment, not from the assignment. But if you solve all the assignment by yourself and practice them, they will help you to score better in the examination. So again, the question will be mathematical 50% and 50% theory questions exam. That I say I cannot reveal. But I said you don't need to remember very complex expression. That I can only reveal about the examination. Anything that is difficult to remember will not be asked in the examination. So I consider when I set the question paper, I consider I am going to write the exam. So if I cannot remember the complex expression, how I don't expect you are remembering those. That's only I can say about the fraction of the mathematical and theory component in the examination. So as there is no more question, we can close this live session. So I would say good luck for your examination and stay safe during this pandemic time. And if you have still some questions in your mind before the examination you want to ask, please write to me. You can find my email ID on browsing the internet. I'll try to answer through that. Or we still having, I think, the portal open where you were getting the assignment and all your queries. You can post your question there also. Thank you very much and good luck for your examination.